begin from the easiest case, the ellipsoid. It is called ellipsoid because if you compare the equation with the ellipsoid, they are pretty similar, right? So the principle is still the same. So x squared divided by a squared plus y squared divided by b squared plus c squared divided by c squared is equal to 1. X intercept. If I want to figure out the x-intercepts, what are we doing? We said y and z are both equal to 0. Right? The intercepts are the intersection between the surface and axis. On the x-axis, y and z are both equal to 0. So we're getting x squared divided by a squared is equal to 1. So the two intercepts are minus a and a. Okay? Minus a and a. So I want to graph my ellipsoid together simultaneously. I'm trying to find all the required information. X, y, z. So the x intersections are a and minus a. So the y intersection, we need to set up x and z to be 0. So y squared divided by b squared is equal to 1. So we have minus b and b. So this is a and minus a. So b might be different. So I will do minus b and b. And z intersection, we're setting x and y to be 0. So z squared divided by c squared is equal to 1. So minus c and c are the two z intercepts. Minus c and c are right here. With only the intercepts, it's pretty hard to imagine what the picture looks like. Right? They are just points. It tells you where the surface will intersect with these three orthogonal lines. But only with these 6 points, it's pretty hard to imagine what exactly does the picture look like. That is essentially why we need the traces. Right? So xy trace. Xy trace is the intersection of the surface with xy plane. What do the points on xy plane have in common? Not really. The point is on xy plane if and only if z value is equal to 0, right? In fact, the equation for xy plane is z equals 0, right? So in order to find the xy trace, I'm letting z equals 0. So x squared divided by a squared plus y squared divided by b squared is equal to 1. This is the intersection between the surface and xy plane, which is actually defining the ellipsoid on xy plane. Okay, so this is on the xy plane. So on the xy plane, you can also read out what are the intersections. So the axis, so this is the okay. So this is an ellipse because this is three-dimensional thing. You have to project it onto the xy plane and on to the border. So this is an ellipse on the xy plane. Okay. So similarly, if I want to find the yz trace, what do? You said x equals 0, right? Remember, these things, even though we're beginning with the ellipsoid, everything else will be exactly the same. I find the intercepts by letting x, y, z pairs to be equal to 0. I find the traces by letting one of the three variables to be equal to 0. So y squared divided by b squared plus z squared divided by c squared is equal to 1. This one defines an ellipse as well on the yz plane. The yz plane is the plane right here. So it's the orthogonal plane coming out of the board. So it's going to be this thing. ellipsoid looks like this. Okay? But if you want to include all the traces in the picture, this is going to be what it looks like. Okay? Questions? This is probably the easiest one. This is probably the easiest one. And unfortunately, the pictures are, if you're not happy with this picture, we didn't see other ones. So if you have your textbook with you, it'll be much better because I have my textbook with me. If you want to see nicer pictures, I don't really want to waste my time by turning on a computer and give you all the good pictures right there. So please, if you have your textbooks, so I think this is you can look at there's really, really nice pictures in the textbook. And one of them, they only have the traces in the XYZ space. So you can look at the traces separately with the surface itself. And then they have different colors. You will have a pretty nice understanding of what is this. Okay? And for this particular guy, it's pretty easy to understand. So let's move on to the second case. Second case is elliptic parabolic. And the standard equation is A is equal to x squared divided by a squared plus y squared divided by b squared. Okay? So this is the standard equation for an ellipsoid. Still second order equation. I want to have the picture right here before I even give you the intercepts and traces. So you can have a first impression right here. Okay, so this is an elliptic parabolic. Okay. Next, I want to put my information of the intercepts and the traces onto the surface. Like I said, every time we have a geometric object, I want you to understand in those ways. If I have the equation, I should be able to tell the intercepts. I should be able to tell the traces. On the other hand, if I know where these intercepts are and which type of them, I should be able to see with the picture. Okay, they should go both ways, from the equation to the picture and from the picture to the equation. Okay? So let's quickly find out what the intercepts are. So x, so this is elliptic. Sometimes it is just referred as parabola. Sometimes people just call it parabola. Because there are a couple of other parabolas. So we have hyperbolic with one shape and hyperbolic with two shapes. Sometimes they will specify by saying it is an elliptic parabola. Okay? So x-intercept. Johnson, what are the x-intercepts? Well, in order to find that, I put z equals 0 and y equals 0. Like I said, do not be scared about anything. There is a principle for every single problem in a whole semester. You just follow the principle. You shouldn't be lost. So x-intercept means y equals z equals 0. No matter what equation I have, I just plug in these values in there. What comes out is what is needed. Okay? So I have 0 is equal to x squared divided by a squared is plus 0. I solve for x. So there's only one x intercept, which is x equals 0. X is equal to 0. And from the picture, this is pretty plain. This is the x-intercept right here. Okay? So y-intercept. This is x is equal to z is equal to 0. So Jonathan, what is y-intercept? So I plug in the equation, I'm getting y equals to 0 as the only intercept. From the picture, it's the same. This is the y-intercept as well. Right? This is actually also a z-intercept. because it is in the origin. But just to make sure, z-intercept I'm making x equals y equals 0, I'm getting z equals 0 as well. So the intercepts are all at the origin. So this is the intercept of an elliptic parabola for x, y, and z. Okay. Next, I want to find x, y trace, y, z trace, and x, z trace. I'm trying to remember more names in here. Elliot. Elliot comes into mind. So if I want to find x, y trace, what do I do? Z equals 0, exactly. And I'm looking at the equation over there. What does z equals 0 mean? Equals 0. And this equation, what does this equation tell you? So I ask you this question. What's the first impression you have about squares? They're positive, all right? Or more strictly speaking, they're non-negative. So if you have a lot of squares, you should have this reflection. Okay, all the squares are positive. And the only thing they can add together and get a 0 is they're all 0, all right? So if the very first impression about squares should be non-negativity. These ones are all negative, and add them together has to be also non-negative. Equals 0 has to be all 0. So the only x, y trace as a curve will be a degenerate curve, because this is not a curve anymore. It's only one point. So x, y is just equal to 0, 0. So on the xy plane, as you can see here, the intersection is not a curve anymore. It's degenerate curve. It is equal to the origin. Right? So this is the x, y trace. Still, how about y, z trace? What's the principle? X equals 0. Very good. X equals 0, looking at the equation, I'm at z equals, I should really copy it over here, so you don't have to look it over and over again. That's the equation we're looking at. So setting x equals 0, we're getting z equals y squared divided by b squared. Remember, b are just, ABCs are just real numbers. So this equation defines what is this equation? Z equals a constant times y squared. It is a parabola on the yz plane opening to the positive direction of the z-axis. You agree with me? Okay. So this is the positive direction of z-axis. So on the yz plane, the intersection is exactly what I have here. Okay? It is opening upwards, and it is a parabola. Okay? So very last, I'm having x, z trace. By x, z trace, I have y equals 0. So the equation is z equals x squared divided by a squared. So this is still a parabola, and it is opening to the positive direction of the z-axis as well. So I'm adding this one extra curve on at a point. So this is another one. This is z equals y squared divided by b squared. This is z equals x squared divided by a squared. They are both parabolas. So these are the traces and the intercepts. The first example, I'm getting the information, and then I determine the curve. The second example, I actually give you the surface in the beginning, and I put all the conditions I have onto the picture. Okay? Questions? Okay, so I have two remarks to make. First remark is about these traces, especially about xy trace. Xy trace is the equation when you set z equals 0. I can in fact set z to be different values. For instance, I can set z equals 1. I set z equals 1. This is going to be the equation x squared plus a squared this multiple times. In the equation, if there's only linear terms, it has to be a plane, right? This is the plane. Not only it is a plane, it is a parallel plane to x, y plane. Know what I mean? It is a parallel plane with x, y plane because they have the same normal vector. The normal vector is 0, 0, 1, am I right? So this guy can be written as 0x plus 0y plus 1z is equal to 1. It is definitely parallel to the xy plane. Is equal to 0. Know what I mean? So I said z equals 0. It is nothing but the intersection curve between the surface and the plane, which is parallel to the xy plane, but a little bit higher. Do you agree with me? So this is exactly what I did. If I draw a plane which is parallel to xy plane, but at height z equals 1, it will intersect with the surface at a curve which is exactly defined by this equation. And I know this equation defines an ellipse, right? And that's exactly the